Good afternoon, everyone, and welcome to the Tough Rhineland webinar um, on asset integrity and really how we can scale this up into a global level and improve the integrity on our sites. So I'm delighted to have two speakers with us today, Connell Brown and Sergey Putinsev. So they'll take you through the main part of the presentation. I'll do the intro. One small apology from my side is I've had a nightmare with the IT, so I have to skip between two presentations, between the intro and the main one. The computer just wouldn't allow it any other way. So we'll do that, but that should be literally 30 seconds, and then we'll be into the main presentation. Okay, so everyone is muted. You can submit your questions on the Q&A in there, and the event is being recorded. So hopefully that's okay. That enables us to share this event with people who aren't able to join the webinar as we're doing it now. I literally have two slides on the TUV Rhineland Industrial Services. So part of the business has come from ABB. So that's the business that I've come from and where Connell's come from. So, and we work with operators in delivering safe operations in the asset integrity, process safety, and the projects world, helping them make smart decisions and sustain the performance of their operations. But also, TUV Rhineland has a large business in condition monitoring, in advanced NDT solutions, and that's where Sergey comes from. So we've joined those two together. We are seeing ourselves operate much more with customers utilizing both elements of the business. So hopefully you'll see part of that today through the webinar. And you can see, we got three drivers in there around sustainability, helping customers decarbonize, and also extend the life of their existing facilities. And you'll see elements of all three of those in the presentation today. I'm only going to show one slide on this because the slide on the right-hand side, the case study on the right-hand side, is what a lot of the discussion will be on, or the webinar will be on today that Connell will take you through. So I'm not going to show any more of that. With that, I'll switch over to the other presentation that has the safety moments, and then I'll hand across to Connell and Sergey. So apologies, we've had to go from one to the other. Okay, so just thinking of what sort of safety moment is in there. We put this safety moment. This is a PSM conference where we're trying to work with the industry in sharing sort of energy transition, but also helping people maintain their process safety. Stay a lot of it to asset integrity. So if anyone's interested in really to collaborate, work across both UK and globally around the process safety, I think it's a great opportunity for you to come along, hear what we've got in Tough Rhineland, and also, how different operators, majority of the speakers here. So this is sponsored by the CIA, Chemical Industries Association in the UK, and the Energy Institute. Majority of speakers are not Tough Rhineland operators who are trying to maintain safe operations in there, and really looking at how do we manage PSM as we go through energy transition. We're seeing hydrogen being introduced into a lot of sites. We're seeing a lot more coma sites are being generated as we go through this energy transition. So great opportunity if some of you are available. And this is the end of this month, 30th of November. Okay. So with that, I'll hand over to Connell Brown. Connell, do you want to introduce yourself quickly?
Hi everyone, my name's Connell Brown. I'm a mechanical engineer and I work in the Integrity Management Department of TUV Rhineland Industrial Services. And I'm going to give a brief presentation about a project I've been working on for the last few years. Next slide, please, Alan. So this project was with a oil and gas company, MOL, like Alan says, and it was with specifically their downstream organisation, which consisted of 4 refining and petrochemical sites across Hungary, Slovakia, and Croatia. And at the outset of the project, these companies have been bought by acquisition largely, so they came in with different approaches to asset integrity management, and alongside that came different processes, different standards, and different software tools. And as a result, they had 4 different levels of organizational maturity and effectiveness in terms of integrity performance. So the project started with a short enabling study to align expectations towards the end of 2019, and the main project started in February 2020. We all know what happened in March 2020. So we had quite a interesting time figuring out how to deliver this project largely remotely for the first year to 18 months. But we made it, and we'll continue to provide support until the summer of 2024. Next slide, please, Alan.
There you go.
So the objectives and charter for the project were to transition the organisation from a reactive to a more predictive, preventative maintenance organisation, inspection organisation, by basing decisions on equipment condition and the risk of failure. The Central European regulatory environment is very compliance driven, and as a result, their inspections were quite compliance driven. So they were inspected to the regulations rather than inspected to the risk. So the idea was by adopting asset integrity management systems, they'd identify the most critical assets and focus inspection and remediation activities at the highest level of risk, both in terms of safety and production, and therefore improve performance, improve uptime, and as a consequence, reduce operating costs. As much as the sort of KPI outcomes, the idea was to get one team working across the site, so one asset integrity organisation working in a common way across the 4 sites, and also to transfer knowledge into the MOL team so that they were capable of sustaining the integrity program once we'd stepped away from the project. So this vision encompassed improved integrity assurance, the reduction in turnaround durations and costs, and then as we move to a risk-based and away from a compliance regime, increasing adoption of non-intrusive inspection and advanced NDE techniques that allow us to reduce intrusive inspections, push out inspection intervals, but while doing that, get a better handle on understanding equipment condition. Next slide, please, Alan. So the scope of the project related to 11 key asset integrity elements. This might not be the full scope of everybody's asset integrity program, but this is what MOL wanted to include in scope. So we had data management, criticality assessment, corrosion control documentation, corrosion control and monitoring, integrity operating windows, risk-based inspections and risk-based inspection management, more general inspection data management, fitness for service, dead leg management, and corrosion under insulation. Next slide, please, Alan. And then the delivery methodology for this project had, like I say, there was a short enabling phase just to get the alignment on the vision and agreement how we work together. But the main delivery phase had 3 phases. The first phase was to show. So this was where TÜV experts in RBI and materials showed the site how to work in an effective asset integrity management program. So the first point of this was to develop procedures. So we agreed on the scope and content for some procedures. Then we went away, wrote the detail, and then the MOL team commented, bought into those procedures, and we agreed that was the way we were going to work on the project. And then we started to implement according to the procedures, do the work, and we'll introduce what that involves in the next slides. But basically, the TÜV team was leading the work, and the MOL team was supporting the process, providing the data, reviewing the outputs, and learning as they were supporting this. Then in the second phase, we moved into teach and coach. So this is where we were working collaboratively to deliver the project. So then the MOL team were starting to deliver the reviews themselves with TUV support. And while we were doing that, we were teaching and coaching the MOL personnel, getting their competence up to the level where they were ready to deliver independently. And then the third phase, the phase that we're currently in now, it was the support phase, where this is where the MOL team lead and deliver the AIM reviews, implement across additional units, the AIM program, and then TUV provide support and review. So we do periodic visits to the site and just check how well the team are implementing or continuing to implement according to the agreed procedures. Alongside the procedures, there was also implementation of software. For this project, we partnered with a company called Metegrity to implement vision software on the site. So alongside the training in the procedures and in the RBI and the other aspects of the integrity program, there was also training and implementation of the new software so that they had a common software package across the 4 sites. Whereas as before, they had different software packages that had different capabilities. So it's moving to a common tool and then common procedures. Next slide, please, Alan. So this is an example implementation on one of the units we looked at. So this was an atmospheric distillation unit. The unit was put into operation in 1967, and it was designed to process Russian crude oil, which is a very good crude oil. It's a very clean oil. It's not aggressive. It was designed to produce 2.2 million tons a year, but the current capacity has been uprated to 3.2 million tons a year, and it's taken a much more varied crude mix now. Some of which crudes is much more aggressive, and of course the integrity consequence of that mean that this distillation unit has got a lot more possible degradation mechanisms, and it's subject to a lot more degradation risks than it was originally designed for. So a lot of integrity challenges for this unit. Within this project, we reviewed a number of static equipment items. So vessels, tanks, piping systems, and safety valves. Next slide, Alan. So the first step was to do a criticality review. So we reviewed a total of 105 vessels and identified that 11 were critical. And then we identified 106 piping circuits and identified that 48 of those were critical. And the criticality matrix was a simple sort of 2x2 matrix. And then those critical items, we took those forward into RBI, and then the non-critical items, they still went through a risk-based approach, but with less detail, which was allied to the lower criticality score that they got. Next slide, please, Alan. So in terms of information and management of data preparation, we had to collect an awful lot of data with the support of the MOL teams. We gathered that information together, and then we imported it into the Visions software. And then once we'd done that, we supported the creation of the corrosion control document. So that included defining the corrosion circuits, marking up the P&IDs to identify what the circuits were, and then putting the detail into those CCDs, corrosion control documents, at the circuit by circuit level. Next slide, please, Alan. Then we did the equipment reviews. So in the project, we split this across two phases. So in the first phase, the sessions were led with TUV with MOL support, and in that we did 41 RBI for the critical and inspection plan reviews by the for the non-critical items, and then for piping we looked at 45. So as at the end of the first phase, the TUV team led the production of those 90 inspection plans, some of which started with an RBI, others which didn't have an RBI, but they did the other elements. We looked at IOWs, dead legs, we did CUI assessments where appropriate. And then in phase 2, the teaching coach phase, this was where now that Mol both collected the data and took the lead in the studies. TUV confirmed, that the methodology, made sure that they were following the methodology that we'd set out in phase 1. We coached and supported the team, and we reviewed and validated the outputs to make sure that they're reaching the compliant standard. So then the balance of the circuits were then done by the Mol team, and then a lot of the circuits we did because I guess the more challenging work was the vessel assessment. So that's where the best value to the Mol team was for them to lead the vessel and heat exchanger tank assessments. Next slide, please, Alan. So as a result, by the end of phase 2, we'd assessed the criticality of all items on the unit. We developed a corrosion control document. 7 IOWs were designed. We created inspection plans and intervals for the static equipment on the unit, and it was all defined by the risk level as per the criticality or the RBI outcome. And then we produced 700 inspection tasks, and that was a mix of risk-based and regulatory inspection tasks. The team created inspection sketches, identified over 3,500 TMLs, did corrosion under insulation assessments for all relevant equipment, and also we carried out non-intrusive inspection assessments, and we found that 22 out of 32 vessels were suitable for non-intrusive inspection, and 1 out of 6 tanks was found suitable for non-intrusive inspection. And Sergei's presentation will go into a bit more depth into the NDT techniques that can actually make the NII happen in practice. Like I said earlier, because they are in a compliance-driven regime, not all of these equipment could move over to a non-intrusive assessment, but we had the evidence to make a case to the regulator for a future change in the inspection requirements. Next slide, please, Alan. So the expected outcomes from the project were a 25% increase in integrity assurance, a 10% increase in availability, 50% reduction in turnaround duration, 10% reduction in turnaround cost, and subject to regulator improvement, a 30% increase in the amount of non-intrusive inspection done. So these are the sort of quantitative benefits that we expect from the study, but the real sort of benefits that you can validate is that the people development. So the teams across the 4 sites really did develop this capability to work independently to an agreed standard and ensure a long-term sustainability of this AIM program once TUV step away, and that's validated by audit visits which are ongoing in the current period, which are coming out with good results, with some minor comments, but generally the team is working independently to that achieved standard. For the process, we have this common work process that increases transparency across the sites, allows for consistency, and most importantly allows the team to share knowledge. So where one team has looked at a unit and reviewed the equipment in that unit, another team on another site with similar equipment can refer back and see, have they missed any degradation mechanisms? Have they not spotted any NDT techniques that another site's using that they could potentially adopt? And then in terms of the technology, we've got the single software that allows for efficient work processes, and that's been very recently migrated from a cloud solution to an on-premise solution. It's going to be integrated to SAP now that it's on-premise, and really this integrity program is going to start becoming part of the day-to-day work activities as it integrates with the creation of work orders and notifications within the maintenance function, that the two are really going to be able to dovetail together. So then just to summarize the learning from the project, the three-phase approach worked really well. So that ongoing transition from the consultant providing most of the input to the client, that really well. The remote work was shown to be possible. We had to do it during the pandemic, but the face-to-face interaction is always better. And finally, the criticality assessment. We worked in 3 different countries. This word criticality seemed to set off red flags. It's a loaded term. So if you're doing a project with different countries, make sure this word criticality is understood by different disciplines and different functions across the different organizations that you work with, because that's one challenge that tripped us up again and again through this project. So that's everything from me.
Go to the next one so that I'll quickly talk about the agenda. So in the next 15-20 minutes, I will tell you about non-intrusive inspection, what it is, what are the benefits of using non-intrusive inspection, and I will give you some examples in a case study. And I will also talk to you briefly about the performing non-intrusive inspection on stream while the plant is still operating, and what additional benefits it will bring to you. So I will share with you some examples and a case study as well. The most important for me is to show you the importance of non-intrusive inspection and condition monitoring for successful implementation of asset integrity management programs. So let's start. Yeah. Next slide, let's look what is non-intrusive inspection. Non-intrusive inspection, or NNI, is basically a process in which planning and evaluation of in-service vessel inspection can allow to replacement or even deferment of internal visual inspection. Basically, in another word, it's performing inspection from outside of the vessel without entering inside and performing inspection from inner surface of the equipment. There are no specific standards related to non-intrusive inspection, but the best known one is recommended practice 103, which was originally produced by DNV, and a lot of people still recognize DNV recommended practice G103, but then this document, the ownership of this document was taken over by Hoist. Hoist is UK joint industry project, which has a combination of members from operators, from NDT companies, as well as from regulators. So they took over the ownership of this guide, this recommended practice, and the latest version was published in 2020 under the Hoist RP 103. And this is probably the most common document that's used worldwide for implementing non-intrusive inspection. Next slide, please. Yep. So what's the benefit of non-intrusive inspection compared to internal inspection? And obviously there are a lot of very significant benefits from non-intrusive, especially when the maintenance or repairs of the vessels are not required. So therefore, there is no other need to empty vessel tank and prepare it for the internal inspection. And in these particular cases, the non-intrusive inspection, and later on I will tell you, on-stream non-intrusive inspection has a lot of advantages. I mean, first of all, it's a safety element because it avoids human entry side of a vessel commonly, which is a confined space. And please bear in mind that it's not just in inspector who enters the vessel. It's a very large number of other personnel, the cleaners, the maintenance people to prepare, for example, scaffolding, to prepare the surfaces, and also even the operators themselves, because commonly they need to supervise the confined access entry. So there is a number of people who would have to come inside of the vessel, and that all creates additional safety hazard, which can be avoided by inspecting the vessels from outside. Secondly, non-intrusive inspection requires much less preparation of equipment for internal inspection, and that overall will save time of the turnaround. So you can reduce the duration of turnaround by doing the inspection from outside of the vessels rather than preparing them and then putting them also back in operation. I can share you one of the recent examples when we had to perform intrusive visual inspection, and the vessel was out of service for 2 days to prepare it and then to put back into the operation, and the whole inspection took only 2 hours. So out of 48 hours not being able to use the equipment, actually only 2 hours were needed for our team to perform the internal inspection. And that gives you a little bit magnitude of how it works. Obviously, you'll have reduced manpower and resources required for inspection, which overall helps with the simplified planning and management of turnaround. There are environmental benefits because you don't need to drain, purge, clean the equipment, and then waste all the cleaning media that you're using. And let alone you avoid potential damage or contamination of the equipment, any mechanical disturbances which otherwise you will have to do to the vessel when you're entering inside. And last but not least, all non-intrusive inspection commonly require advanced NDT technique, which means that all the data you collect is in electronic digital format straight away, and this extremely valuable data for your risk-based inspection and fitness for service assessment. Next, please. So what advanced NDT techniques are used for non-intrusive applications? This is not an exhaustive list, but this is what TÜV Rheinland is using on a regular basis for in-service weld defects, which is, I would say, one of the common application. We're applying time-of-flight diffractions, TOFT, and phased array UT. Another very common issue and challenge that experienced by most of our customers is the corrosion, general corrosion, but also corrosion and insulation. So there are a few techniques that we apply. One of that would be pulse eddy current. We are very experienced in performing inspection. It's a screening technique without removing of insulation. If you have vessels or tanks, that another very effective technique for screening for leakages, cracks, as well as the active corrosion is acoustic emission testing. And if you have pipelines, also commonly under insulation, then we would always recommend long-range UT, sometimes called guided waves. This is also a very good technique for your non-intrusive inspection. Yeah. Lastly, I mentioned high temperature hydrogen attack as a damage mechanism because it's very severe and dangerous damage mechanism happening commonly in the chemical, petrochemical industries on aging plants. And the trick is here, requirement is to detect the HTHA damage at very early stages, which is very, very difficult. And for that, you need to apply a variety of advanced non-destructive techniques in order to screen the material and find the early indications. Next, please. So once you established that you can apply non-intrusive inspection approach, and it's part of your inspection strategy. You need to develop a methodology. And again, we would recommend to follow the recommended practice 103, where it's quite well defined the process of non-intrusive methodology. Commonly, you start with definition of vessel zones, because the risks of the vessel depending on the zones, and that's why you kind of put them in a different high and low category zones. You need to define degradation types and damage mechanisms. This is absolutely necessary. And on that basis, you preparing your inspection work scope in terms of locations, the coverage, which is based on a number of factors listed here. You need to factor them into the calculation. And then at the end, then you have your locations that needs to be inspected, and you select the inspection and advanced NDT technique that is the most applicable technically to provide you with the data that you want to achieve. Because obviously, if your damage mechanism is corrosion, then you're using advanced NDT technique, best focusing on the corrosion. If you have some stress corrosion cracking, for example, or if you have cracking in the wells, then obviously you need to select a different NDT technique to establish that. Next, please. One quick case study, which is good illustration where non-intrusive inspection works very well. Our colleagues were performing statutory regulatory inspections on at an offshore installation, and one of the equipment that required internal inspection was diesel storage tank, and that was the only source of fuel for powering all electricity on an offshore platform. And for obvious reasons, performing inspection from inside would means that all the diesel will have to be moved out of the tank, and that would physically stop all electricity supply into the platform, which the owner obviously was not able to afford without very thorough planning and shutting down the whole platform for the duration of inspection. So our task was how to assess the condition of the tanks without actually stopping its purposes. And it was quite an old, over 40 years old asset with history of corrosion and small internal lining issues. And obviously there was critical risk of environmental as well as a production threat if there is some problem with the tanks. So the solution that we offer to the customer is to perform, first of all, non-intrusive inspection assessment to determine which locations can be inspected from outside and by which method. And we applied Hoy's recommended practice for that. And that was accepted by our customer. And as a result, we performed inspection using the phased array technique from outside of the vessel, looking also both for corrosion and for certain cracking areas. And all inspection was performed outside without a need to empty, clean, and internal entry to inside of the tank. So we fulfilled the inspection due date, the statutory inspection due date, without any postponement and without any impact on the operation of the offshore platform. This, of course, was example when the tanks was operating. It was just a storage tank, so there was no process in it. So it was working under ambient temperature. So that was quite straightforward way to apply non-intrusive inspection. But however, you can apply same methodology also on your process equipment when it's working. And this is, of course, from one side, much more complex non-intrusive inspection approach, but also giving you a lot of commercial and operational benefits. And I would like to say a few words about this as well. Alan, if you go next slide. So I would like to say that, okay, how can you then perform non-intrusive inspections on stream when the plant and the process equipment are still operating, and how you can also add remote condition monitoring to collect verifiable integrity data of your equipment, and do all of that without stopping the plant, without doing it either during turnaround or during unplanned shutdowns. Let's look at that. So if we look at the benefits of on-stream non-intrusive inspection, they are, first of all, the same what we already had previously. But if you just click on one more without... But in addition, you have some very significant further benefits. And the biggest benefits that we can see and our customers are feeling, first of all, it's a reduced turnaround time, because you can significantly reduce the scope of your turnaround inspections by performing pre-turnaround inspections. So you're moving some inspections from your turnaround windows into time when you can plan it, you can prepare everything from outside, and you're not scheduling it at the same time when you have maintenance, when you have other inspections, and a lot of things happening during the turnaround time. Secondly, very important, you optimize your inspection and maintenance planning for the turnaround, because you're already getting a lot of data about location, size of your damage. You know exactly what to repair, when to repair, what materials you need. You can pre-order some replacement. So that's another great advantage of doing it on stream. And potentially, depending on situation, case by case cases, but we had examples when you can agree with the authorities that some of the inspection can be done on stream without performing the same inspection during the turnaround, that reduce your overall scope. The other very important benefit of on-stream is also to prevent, or at least minimize as much as possible, unplanned shutdowns, because basically you can increase the frequency of inspections without interrupting your production. Commonly, you're doing shutdowns, I don't know, every 12 months. And if your damage defects are happening during this 12-month period, then the risk that something happens high, and waiting for another 12 months for the next inspection could be quite risky. So increasing frequency of inspection helps you to control, to monitor any damage developments or any defect developments in the plant. And that also gives you confidence in lifetime extension. A lot of plants that we're working on are above their designed lifetime, and condition monitoring, really good example for good benefit for that. And lastly, when we talk about monitoring tools, then you use them not only for your integrity management, but also for optimization of your production, because then you can immediately see any changes in the corrosion rate, for example, as a result of any changes in your process, and you can optimize both on that basis. Next, please. So what example, once again, it's same non-intrusive advanced NDT applications that I used before. But Alan, if you click just once, one of the few companies worldwide that provide these non-intrusive techniques on stream, commonly under the high temperature. And as you can see, basically we go up to 350 on all of the techniques. Pulse current generally doesn't require high temperature because it comes through insulation anyway. This is only applies when instead of insulation you're doing coating and client doesn't want to reduce or remove coating, and that's why the surface temperature could be already quite high. But for all other techniques like Toft and phase array, we're going nearly up to 500 degrees C, and this is the surface temperature of the objects that we are inspecting. And when we're talking about remote condition monitoring, and I have a separate slide next on that, then depending what you monitor, we can go even very, very, very high temperatures. Very important to mention that there are no international standards for high temperature NDT inspection. So everything is bespoke. The testing is performed on the basis of internal procedures, which should include specific test validation on a mock-up, as well as very strict safety requirements, because as you can imagine, you can see it's a little bit on the pictures there, performing inspection at high temperature causes quite a lot of safety concerns for the operators, but our team is very much experienced and doing this for over 20 years. Next one. I promised to say a few words about remote condition monitoring, because the difference between how to say non-automated condition monitoring is that you can collect this data through periodic inspections on a regular basis, but you can also obtain similar data by placing the sensor. And there are different types of monitoring, very commonly known for many years already. It's vibration monitoring on rotating equipment, but nowadays we see more and more developments into the static equipment, and here we're mainly talking about corrosion as well as creep and creep fatigue. Within our company, we apply all of that, dealing with vibration monitoring, but also corrosion monitoring. You can see example on the right-hand side on the PIMS, as well using UT sensor, and on the bottom right example of the corrosion monitoring using pulsed current on high temperature. And then we also have various strain gauges in order to monitoring the creep and creep fatigue on various plants. And I'll share with you just one case study for on-stream non-intrusive inspections. I have to say this was quite typical from we performed this job in South America, where there was a damage indications found during the turnaround inspection on two critical vessels. It was the diesel reactors, quite big, 17 meters high, but for customer had to put both of them back into the in service and requested to confirm the presence of the defects, but more importantly, locate and size them so that the maintenance and repairs could be planned accordingly. So what we offered customer to perform on stream inspection, the high temperatures, the temperature of the surface was 370 degrees with a wall thickness of 114 millimeters. We applied our Toft and phased array technique to make it very efficient. It was quite a big team from our side there, over 12 people, plus the project manager. And we, as a result of our inspection, we confirmed the damage, but more importantly, we located and sized the damage, and that allowed customer to schedule the necessary maintenance and repair and prepare everything, because we knew exactly some replacement equipment they ordered, and the rest they prepared for the repairs during the short-term plant shutdown for that. So that's just one of the example how you can apply this on stream. And my last concluding remarks, so that we have some time for the questions. As I mentioned earlier, non-intrusive techniques play a very important role for any RBI and overall your asset integrity management. The methodology is widely accepted by the industry and also by the regulators, which is important. And the non-intrusive inspection and advanced NDT and condition monitoring bring a lot of benefits, safety benefits, sustainability benefits, cost reduction, but more importantly, increase of production by avoiding the stoppages, avoiding planned or unplanned shutdowns. We certainly recommend to follow the recommended practice from HOIS 103, very good document, a lot of guidance there. And please use the competent and experienced people for non-intrusive assessment, especially for on-stream applications, because the material properties change significantly. The equipment, the test equipment and DT test equipment changes also significantly. And this is the reason why there are no standard international standards for high temperature inspection. Anything above 60 degrees Celsius require bespoke approach. And lastly, remote condition monitoring using the sensors, very, very effective technique to optimize your plant operation and also keep it within the limits of your integrity operating window. Thank you very much.